structuring and evolving so that EMS supports desired results. The changes we are making are driven by results, not by the system itself. EMS is a tool designed to support necessary improvements, not a framework that dictates how we must operate. While the focus is on what needs to improve independent of EMS, but EMS will be structured to enhance and facilitate these improvements, not the other way around. Well, this is about building a system that serves ARH goals, not forcing ARH to change just to fit into a system. The goal is to optimize processes, enhance efficiency, and remove barriers to execution. These are priorities that would be necessary regardless of the system in place. EMS simply provides the structure to make them more effective and scalable. Understanding systems, definitions, interpretations, and applications. The term system can mean different things depending on context, which often leads to misalignment in discussions and execution. To work effectively within and across teams, we must recognize the different types of systems and how they function. At its core, a system is a structured way of organizing and executing tasks, resources, or processes to achieve a specific outcome. However, the level of rigidity, adaptability, and purpose varies significantly. 3 key interpretations of systems. A. Defined and rigid systems, concrete systems. These are rule-based, structured, and operate with minimal flexibility. Examples: accounting frameworks, compliance policies, manufacturing processes, chain of command hierarchies. How to work within them. These systems exist to ensure consistency, control, and reliability. Deviation often leads to failure, inefficiency, or risk. Misinterpretation risk. Some may see them as restrictive, but they are designed for predictability and stability. B. Technical and operational systems. These include tangible software platforms, workflows, and tools used to manage information, processes, or automation. Examples: enterprise management systems, EMS, Deltek Vantage Point, project tracking software, IT infrastructure. How to work within them. They require proper implementation, adherence, and ongoing refinement to remain functional. Misinterpretation risk. If someone sees a technical system as purely optional or flexible, they may bypass critical steps, leading to inefficiencies or data loss. See philosophical and adaptive systems, strategic and playstyle systems. These are broader guiding principles, frameworks, or styles of execution that shape decision-making and collaboration. Examples: play within the system in hockey, an organization's leadership philosophy, or how ARH balances autonomy and enterprise-wide coordination. How to work within them. These require understanding the strategic intent while allowing for situational adaptability. Why a thermal exhaust port, TDP, metaphor? There isn't a perfect term that simultaneously captures both a flaw and a vulnerability in the way needed to illustrate this concept. A flaw implies a mistake, something that should have been avoided or corrected. A vulnerability suggests exposure to risk, but in reality, everything is vulnerable under the right circumstances. The thermal exhaust port, TEP, metaphor works because it represents a known weakness that wasn't necessarily an error. In the design of the Death Star, the TEP was a functional necessity, not an oversight. The engineers likely never imagined that a single X-wing fighter, penetrating multiple layers of defense, could deliver a precision strike through such a small opening. So while it was a vulnerability, it wasn't necessarily a mistake. In our enterprise, we have elements in our system that function in a similar way. Well, they aren't design errors, but they create points of exposure. Well, they are necessary for function but require awareness and protection. Well, the solution isn't always to eliminate them, but to design around them, either reinforcing defenses or preventing the shot from happening in the first place. So when we use the term thermal exhaust port, it means something that falls between a flaw and a vulnerability, a structural reality that we must understand, manage, and protect rather than simply fix. This metaphor helps us identify areas that need safeguards, adjustments, or operational awareness rather than treating them as failures. The real danger isn't their existence, it's not recognizing them before they are exploited. Replacing the wall with redlining, a more precise, actionable approach. Moving forward, we will replace the wall with redlining. For years, a wall represented the point where AR began to struggle under workload and volume pressure, a conceptual barrier that signaled inefficiencies, operational strain, and diminishing effectiveness. However, through our work over the last 3 years, we have moved beyond the abstract concept of the wall and have identified clear targets and goals. Now, instead of focusing on an undefined limit, we will shift our language and focus to redlining, a more precise, measurable, and strategic concept. What is redlining? Definition and metaphor. Redlining comes from automotive engineering. When an engine reaches its maximum safe RPM, revolutions per minute, it enters the redline zone. This is the point where the system is still functioning but pushing any further risks breakdown, overheating, or failure. However, redlining isn't always bad. Owing short bursts, redlining can be necessary for peak performance. Owning long stretches, redlining causes wear and inefficiency. But the key is knowing how to expand the redline threshold, when to pull back, and how to recover effectively. This shift in terminology moves us from a static barrier, the wall, to a dynamic, measurable state, redlining, something we can monitor, manage, and optimize. Why this shift matters: from a fixed limit to a manageable system, expanding the redline threshold. Well, our goal is to increase the point at which redlining begins, pushing ARA's ability to operate at higher workloads without strain, inefficiency, or burnout. This means improving systems, refining processes, and optimizing workflows so that what was once too much becomes manageable. Managing redlining when it happens. Sometimes redlining is by design. Certain high-demand periods will push us to max capacity, but that's okay if we have strategies to recover. Instead of reacting emotionally to workload strain, we will identify when we are redlining and deploy strategies to stabilize. Identifying disruptors that cause redlining. Some redlining happens due to external forces, client demands, economic shifts, unexpected volume spikes. Some redlining is caused by internal inefficiencies, poor coordination, misallocation of resources, unclear decision-making. By tracking the causes of redlining, we can be proactive rather than reactive, anticipating stress points before they become breakdowns. How redlining applies to both the enterprise and individuals. At the enterprise level, redlining represents ARA's operational capacity limits, how much volume, workload, and financial commitment we can sustain before effectiveness drops. B. The enterprise focus will be on expanding the redline threshold through smarter processes and resource allocation. Developing strategies to recover from redlining when necessary. Identifying system-wide disruptors that push ARA into redlining unnecessarily. At the individual level, asterisk redlining applies to personal workload and effectiveness. Asterisk employees must recognize when they are redlining, pushing to unsustainable levels. Communicate and adjust before burnout happens. Learn strategies to recover after high-intensity work periods. Replacing the wall with redlining gives us a more precise, actionable framework to manage operational strain. Asterisk, instead of treating high workloads as a failure point, we will approach them as something to manage, optimize, and strategically push when necessary. Asterisk, the focus is on controlled intensity, expanding capacity, and recovering effectively, both at the enterprise and individual level.